Your lecturer is John Kaiser. Dr. Kaiser is a professor of computer science and engineering at Texas A&M University. He helped create the new Introduction to Programming course at Texas A&M, and he created the required Programming Studio course. He has won several teaching awards, including the Distinguished Achievement Award in Teaching.
Computers are now so common and affect our lives in so many ways that it's easy to think of them as controlling us. But really, we are in control of the computers. Or we can be. That's what computer programming is all about, being able to put yourself in control of the computer, to give it the instructions and commands that will enable it to do what you want it to. And that's what the programming language C++ is known for. It's one of the most powerful programming languages there is for putting you in control of the computer. C++ is used in a lot of major applications in industry, both because of the power and efficiency it provides, as well as its flexibility. C++ lets you program at basically every level you can think of, from the lowest level computer commands where you're manipulating individual bits in memory, all the way up to a very high level, where you're describing generic algorithms that apply across a wide range of applications. And C++ supports multiple programming styles, or paradigms, that have emerged over time. There are advantages to using each of these styles. The newer ones haven't made the older ones obsolete. C++ is particularly strong in allowing you to use a variety of different paradigms in your programs. And as a result, C++ is used as the basis for a wide variety of applications, across many domains and ranging from small applications to some of the most important pieces of software ever developed. C++ has been used to develop many of the programs that you've probably experienced, from Microsoft Windows to the code underlying Google's search, to website functionality on YouTube, Facebook, Amazon, and PayPal. It's been used to control devices ranging from ship engines to Mars rovers. And as expected for a language first developed in AT&T's labs, it's also used in phone systems worldwide. Now, computers operate by following a set of instructions. But the instructions that a computer can understand are a bunch of ones and zeros, a long sequence of binary numbers that encode the instructions and data for a computer to use. Now for people, this is nearly impossible to follow. It's just way too complicated. And so, people have developed programming languages. Programming languages are a way of letting people understand the instructions that a computer will follow. So, when we think of programming, of writing computer code, we should think of it as a way of communicating. We're communicating our ideas and intentions to the computer. And we're communicating to any people reading our code, whether other people or even to our future self. The idea of programming goes way back in time. What's sometimes called the first program was written by Ada Lovelace in the 1840s. And she wrote computational instructions that could run, in theory, on a machine that had been designed but not built. The first modern programming languages were developed in the 1950s, with Fortran being the first one that was really widely used. In fact, Fortran itself is still used today. Fortran was a procedural language, and procedural programming is still a common approach used today, including as a style of C++ programming. Now, since Fortran, there have been hundreds of languages developed, and each one has its own strengths and weaknesses. In this course, we're going to be learning C++. C++ was developed as a sort of extension of the programming language C. And C itself was a descendant of an even earlier language called B. All of these came out of Bell Labs, later known as AT&T Labs. Now, while B never got much use, C, which was developed in the early 1970s, became very widely used, and it still is today. And it was, and is, very good for programming in a way that closely corresponds to machine instructions. while also providing several higher-level features that make it easier for people to understand. In the 1980s, Bjarne Stroustrup wanted to retain the low-level efficiency advantages of C while adding on some of the more modern programming approaches. And thus, C++ was born. One big advantage of C++ was that it added on the ability to do object-oriented programming, which lets you group your data and operations together in more useful ways. Now, C++ really came into its own in the mid to late 1990s, when it started to be used for major projects like the Windows operating system. And it's been a major programming language ever since. But C++ is not only an object-oriented language. Other new features have been added too, allowing it to reflect the most recent advances in programming language design. One area that C++ has expanded quite a bit has been in its support for something called generic programming, which lets you take a concept that works for one instance and apply it to many similar things. And this all makes C++ incredibly powerful, letting you work across a full range of programming paradigms. Like C, you can work in just about as low level of detail as you want, specifying individual bits. Or you can work at a much higher level, using cutting-edge programming constructs that let you write code once and then apply that to a wide range of applications. C++ is also a language that continues to be developed today. There's a large and active international C++ standards committee that's continually working to determine ways to improve the language, including adding new features that integrate the best and most recent programming practices. The versatility and power of C++ makes it my personal favorite language to program in, and I'm excited to get to share it with you. Now, as we go through this course, I'm not going to be assuming that you've experienced programming before. Maybe you have or maybe you haven't. If you have done some programming, maybe in a different language, then many of the ideas and concepts will be familiar to you. But the syntax of the language is probably different. I'm also sure there will be some new and different programming concepts like generic programming that you probably haven't seen before. And if this is really your first time to be programming, well, you've got a great adventure waiting for you. Programming can be lots of fun, and as you learn how to give the computer instructions, you also learn how to attack problems in a logical way. And a common term for this is computational thinking. And the value of computational thinking is becoming more and more widely recognized as a critical skill that anyone can use. We all face complex problems, and learning how to approach problems in a systematic and disciplined way and apply the tools that you have available to solve a problem is a useful skill for anyone. And, to me, C++ is a particularly good language for learning computational thinking skills, since it supports so many different styles of programming. It helps us think of multiple ways that we can solve problems. So, in these lessons, you'll be learning the details of how to write code for a computer program, and how to get the computer to do what you want. But I think you'll also find that you're sharpening your thinking in ways that can be applied to problems even in everyday life. So, let's talk about what happens when we program. As programmers, the thing we generate is a program written in a programming language, and that's C++ in our case. Remember, this program is written in a way that's meant for people to be able to understand it well. The program is just a text file, and we're actually free to write it in lots of different ways. You could use your own word processor if you want, and just save it as a text file. You could use Notepad or WordPad on a PC or TextEdit on a Mac. And there are also editors written specifically to help people write code. Notepad++ is one of these. But I'm not going to be using or expecting any special text editor in this course. Once you write a program, you send it to a compiler. And the compiler is a key early step toward getting our program to actually do something. What the compiler does is it takes the instructions written in C++ and it translates them into machine instructions, the instructions that the computer can understand. So, a compiled program is a program that's machine ready to be run or executed. And we call this compiled version of the program an executable program. And we can then run it on our computer whenever we want. Now, as people develop code, they'll usually go through this process many times to see if it's working. Write some code, compile it to get it ready for the machine, and then run the program. Then write some more code, compile the new program, run it, and so on. To make it easier to develop code that way, programmers use what's called an Integrated Development Environment, or IDE. An IDE will have an editor that lets you write code, usually with some special features to help you write code in that language. And the IDE will have an easy way to automatically save that code, have the compiler compile into machine language, and then run it, often with just one click of a button. And there are usually other features that are built into the IDE, like a debugger, which is a tool that helps us find and fix errors in our program. The IDE integrates all these things and more together in one package so that you can edit and compile and run and debug your code all in one program. Now, as you go through this course, you'll find it much more rewarding and valuable if you're able to practice writing your own code as you watch. So, I want to encourage you to download an IDE that supports C++. I'll describe how to do that in more detail in a special segment right after this lecture that's entirely focused on getting started. If you want to, you can skip ahead and install an IDE now, in case you want to follow along with the code that we're about to see. But if you wait to install the IDE until after this lecture, it should also be just fine. Just be sure to try out the program for yourself. So, let's go ahead and start with our first program. There's a very long-standing tradition in computer science that the first program you develop in any language is a Hello World program. And this tradition goes back to the early days of C, when the developer of C, Brian Kernighan, used Hello World as part of a tutorial to teach C. A Hello World program is just a program that displays a message, Hello World, to the user. Here's what a Hello World program looks like in C++. Now, let's look at how this program is executed. I have an IDE set up, and I type the program into the IDE's editor window. When I tell the IDE that I want to run the program, it will both compile the program and then run the executable that the compiler produced. And when we do that, we see that the result of the program is a line of output, printing out the words, Hello World. So, that's how we write, compile, and execute code. As we go forward, I won't usually show that whole process, but you'll be able to write, compile, and run programs yourself in an IDE with just a little practice. Okay, now let's turn back to the code that we just wrote and look at some of the details. For such a simple program, there's actually a lot of stuff packed in there. The first lines that you'll see are comment lines. The main thing to realize is that comments are a way of giving notes about the code, but they don't actually affect what the code does. The next couple of lines are what we usually call header information. Now, don't worry too much about exactly how these work right now. The #include line is something that gives us access to a stream of input and output. The using namespace line makes it easier for us to write code. And I promise that we'll discuss exactly what those lines do later in the course. But here in the beginning, we can just take what they're doing for granted. Just know that we'll keep seeing and using these lines at the beginning of our programs. The next line that we have is one saying int main and then a pair of parentheses. And this is basically the part of the code marking the beginning of the program. It lets the computer know this is where the code that we want to run begins. Now technically this line is declaring a function named main that will return an integer value like 0. Again, the particular details like why there's the word int and the parentheses aren't important to understand right now. But you should realize that seeing the word main indicates this is the main part of the program. Next, you'll see a pair of curly braces. Curly braces like this are a critical part of C++ programming that date all the way back to a predecessor language in the 1960s called BCPL. And before that, all the way to the way you would write a set in mathematics, like the set containing the numbers 1, 2, 3. However, in programming, in most cases, what's being grouped together inside of the curly braces is a group of commands. So, when you see curly braces, they're grouping a set or block of commands together inside. In this case, the curly braces are grouping together all the commands inside the main part of the program. In fact, when I talk about the main part of the program, I'm referring to the part of the program in between the curly braces that come after the word main. Then, finally, you have your actual line of code giving a command. This is the line of code that actually tells the computer specifically what we want it to do. It commands the output of "Hello World." And this statement is important. All the rest of this program is basically the same as in other programs. This one statement is the key line that does something specific. So let's take a closer look at each part of it. First, notice that the line begins with the word "cout." "Cout" is an expression meaning console output. The console is the default output area. So, "cout" means that there's going to be output, and the output will be going to the console. Its output's the default output area. Now, in an IDE, the default output area might be an output pane within the main window, or it might pop up a new window to be a console window. If you're running the code in a browser, it'll show you the result in that window that you're running from. Let me quickly mention a little bit of terminology. When we talk about output, particularly text output that's going to the console like this, it's common to say that we're printing something out. And when we use the word print, we really just mean display or show. We don't mean print onto paper using a printer. So our program here is going to be printing "Hello World." Now, back to our main line of code. The next thing we have looks like a double less than sign. And this is the output stream operator. The easy way to think about this operator is that the less than signs are like arrows pointing in the direction that the information stream is flowing. In this case, we have something that we want to print. And so that thing that we're printing will flow toward the console output. Notice we have two stream operators on one line, which shows that different items are being streamed in order. The thing to the left will reach the console output before the thing to the right. Now, after the stream operator, we have the text that we actually want to output. Notice that the text that we want to see is enclosed in a pair of quotation marks. And this is also common in C++. We have to use quotation marks to identify text in our code. Otherwise, the letters will get misinterpreted by the compiler. So our words, "Hello World," along with punctuation, a comma and an exclamation point, appear inside the quotation marks. The next thing to get streamed to the output is the word "endl." "Endl" is a way of saying "end line" for output. And this is one way to say, we're done with printing a line. End the line of output here, and go on to the next line for future output. If you don't include "endl," then the next thing that'll be printed out would come immediately after the previous one on the same line. But we include "endl," so the next thing to be printed will come at the beginning of the next line. Keep in mind, the "endl" indicates an end of line in what's output, not necessarily the end of a line of code. And finally, we have a semicolon. The semicolon is what appears at the end of the line of code. The semicolon is actually really important. In C++, it's the semicolon that indicates that we've reached the end of a line of code. Now, just like a period ends a sentence in ordinary English, a semicolon ends a statement in C++. Just like a sentence that we write out can go across more than one line, or we can have two sentences on the same written line, a statement in C++ can go across more than one line, or we can have more than one C++ statement in the same written line. Remember, it's the semicolon, not just moving to a new line, that ends a statement. The only times we don't have a semicolon are for a few special cases. The #include line that isn't actually a command we want the computer to perform as part of the program, but rather a command of the compiler that translates the code to machine instructions, or the curly braces after main, which again are not a command, but rather a way of grouping commands together. But anytime we're finished with an individual command, it'll need to have a semicolon at the end. Now, unlike some other languages, the order and the spacing of our C++ code doesn't really matter much at all. We can put multiple instructions of code on one line of text, with no space needed after the semicolons. Or we can spread a single instruction over multiple lines. The compiler basically ignores everything about spacing as it converts the program to machine instructions. Instead, the way we separate one command from another is using the semicolon to mark the end of a statement. In the main part of our Hello World program, we only had one statement, so we only had one semicolon. So, that's how our first program works. If we run this program, we see the words Hello World printed to the screen. Before we go on, let's try to write a modified version of this program. Instead of printing Hello World, let's print a variation. Now, I teach at Texas A&M, and the school's greeting, which we really use, is howdy. So, let's modify the program to say, howdy, John. Or if you're programming this on your own, have it print howdy and your name. What would the program look like? Well, here's what the program might look like. In this case, it's basically the identical program to the Hello World program that we saw before. However, now the text inside of the quotation marks is howdy, John, instead. Let's look now at how we can generalize a few parts of this. We'll begin back with the first line we saw, a comment. Comments are an important aspect of how code is written by and for people. Comments are a way of putting a message directly into the code itself that will give some information that a programmer might want to know. Now, it could be a short message, like the one in our code here, just saying what the purpose of the program is. Or it could be something that describes what one line of code is doing. It could be a note saying that some part of the code is not working or needs more work. Or it might give information like who was the last person to modify that code. Basically, comments can be anything that helps people understand what the code is for. Comments are skipped entirely by the compiler. When a compiler sees a double forward slash, it always reads what follows that as a comment. And when processing code, it just skips right over it, all the way to the end of the line. So, including comments is purely to help people reading the code. Now, you might be wondering, are comments really necessary? I mean, after all, you're just writing a short program to test something out, not writing large amounts of code for a huge organization. And to some degree, that's true. There's not much need for comments in small pieces of code like the one we have here, compared to how important they are in bigger programs. But getting in the habit of including comments to explain code will help whenever you do end up writing somewhat larger programs. So, if you're writing a comment, who do you think it's meant for? Well, obviously it could be for other people who didn't write the code, but come along later and need to understand it. But just as important is that you're writing the code to a future you. It's surprising how many times you'll write a piece of code thinking it's only going to be around for a short time. And then you discover months or years later that you want to go back to that code. Sometimes it's only a day or two later. But by that time, even if you know the overall purpose of the code, you've probably forgotten what was going through your mind when you wrote it. Comments can help you tell your future self what you had in mind for each part of the code. In C++, there are actually two ways of writing comments. The first is the one we've been seeing, where we begin the comment with a double forward slash. The double forward slash is a way of indicating that everything from that point on in that one line is a comment. In our example program, the line starts with a double slash, so the entire line is a comment. But this double slash is also frequently used in the middle of a line, after some real code, maybe to explain that one line. The other type of comment is one that opens with a slash asterisk and closes with asterisk slash. And this type of comment is helpful if you want to write multi-line comments. It will begin with the slash asterisk, and it will continue until whatever is closed by an asterisk slash, even if that's several lines later. As you can see in this example, we can insert a multi-line comment anywhere we wish by using this format. And we could also easily modify our original program to make the initial comment use this format also. We often use comments to provide visual separation, for example, to create a block at the beginning of a program. Now notice in this example that we've got a couple of lines of just asterisks, providing a visual block of comments at the beginning of the program. And we'll often use a comment to describe what's coming next. For example, we might put a comment right before the main part of the program, just showing what that part is about to do. Okay, so that's how comments work. But we still have a pretty simple program. The real work of the program is all done in just one line. Before we stop, let's see what it would look like to have a slightly more complex program. So here's a program with 3 different lines of code in the main program. That's the program lines that begin just below the int main line. All 3 of these lines are nearly identical. They just print out some text. Each one prints out text on a different line. The first one says, "Howdy, John." The next one says, "Are you ready to learn C++?" And the final one says, "Let's get started." Each output includes an end of line also. Now, this may seem simple, but the main point that I want you to get from this simple bit of code is this. Commands are executed in sequential order. When we have a series of commands, like the 3 cout statements that we have here, the program will handle each of them in sequence, in the order specified. So if you consider a program as being just a series of commands, then running the program is just executing those commands in order. Now later we'll see things like conditionals, loops, and function calls, all of which can change the order that we execute statements. But the basic structure of a program is a sequence of statements which will execute in order. Let's look at just one slight variation on the previous program. Do you see the difference between this program and the previous one? Notice that there's no endl or endline streamed to console output. The previous version had endl streamed at the end of each line. So what will happen in this case? Well, since there's no endline streamed after printing the text, the next time that a print statement is encountered, it will pick up right where the previous stream left off. So, the 3 sections of text are all stuck together in a single line of output. Notice that there's not even a space between one chunk of text and the next. The word "are" starts right after the exclamation point, and the word "let's" starts right after the question mark. Likewise, notice that we could put that end-of-line command in the middle of a stream. In this example, we've streamed all the text in a single cout statement, and we just streamed some endls in the middle of the stream. Wherever those occur, there will be an end of line in the output. So, if we look at the output, we again see 3 lines, just like our earlier program that had 3 separate cout statements, each with an endl at the end. Now let's try one quick exercise. Now that you've seen a little bit more about how output works, see if you can write a program that will print your name and address, the way you would on a letter, outputting that to the screen. You can use multiple cout statements or try to put it all into one. Well, throughout the course, I'll have places like this where I'll pause briefly and let you have a chance to think about and preferably even try coding and answer yourself. When we get to these points, let me encourage you to pause the video so that you can try the problem yourself. Okay, here's how that might look. I've printed 3 lines using 3 cout statements, each one using an endl. My name is on one line, a street address on another, and the city, state, zip code on a third. Or, if you wanted to combine all the output statements on a single line, then your code could look like this. There's just one cout statement with end lines output between each pair of address lines. As we go forward in this course, we'll see how to make more and more complex programs in C++. We'll be learning about the different operations that we can perform with C++, the different ways we can organize our computation, and the different styles of programming. Learning more about C++ programming will be a fun experience, and I look forward to you joining me as we learn more. So far, we've seen some basics of programming. how to write output, and how we can arrange our computation in a series of sequential steps. In our next lesson, we're going to be learning about how to use one of the most fundamental parts of a computer program, a variable, and how C++ lets us create and manipulate these variables. And we'll see how we can do more than just output data from our programs, but also bring information into our programs. For now, stick around for a bonus segment on how to get a C++ programming environment working on your own computer. See you next time.